How are you, my dear students? I hope everything is okay. We have finished chapter 17 and today let's complete chapter 18, States of Matter, section 1, 3 states of matter. What are the 3 states of matter? Of course, they are very easy, which are solid, liquid, and gas. What are the difference between the 3 states of matter? Number 1, if I hold a piece of cube, like a piece of ice cube, okay, this ice cube changes its shape after putting it on this container. Of course, it is still keeping its shape. Okay, will it change its volume? Of course, it can't. So we can say that the solid holds shape or keep its shape, or by another way, it has definite shape. What about its volume? It has fixed volume. If you hold your pencil after putting it on the desk, the shape will change? Of course not. What about its volume? It will change? Of course it can't change. So the solid keep its volume, keep its shape, or has definite shape, definite volume. Let's speak about the liquid. What about the liquid? If I have some juice or some water, after putting it in this container, okay, what about the shape of container? It is like the cube. What about the shape of water after putting it here? It will take the shape of container. So we can say that the liquids have the shape of their containers, and we will see now why. What about the volume? For example, if I put 1 liter of water in this container, after putting 1 liter of the water here, it will decrease? Of course no. It will increase? Of course no. It will be 1 liter in the container. So it has fixed volume because the 1 liter of water still 1 liter here in this container, so the volume doesn't change for the liquid. If I have here the air, for example, the air around you take the shape of your room, take the shape of empty cup, take the shape of the balloon, and so on. So the shape of the gases change because also like the liquid, they take the shape of the container. So gas and liquid are called fluid. Okay, what about the volume? Of course, if I have a balloon filled with oxygen or filled with air, you can press it easily, right? So its volume will change by pressing on the gas. So as we said, solid, liquid, gas, they have different properties. Let's know more. Let's go inside the liquid to see what about the molecules. Here in the solid, we will see that the molecules, as you see, are arranged. What about its motion? They move? Yes, of course. What do you say? The solid can move? Yes. So the wood can move? The particles or the molecules of the wood can move? Yes, they move. The molecules of the iron move? Yes, they move. But its movement is very, very slowly, so we can't feel it. It is called vibrational motion. Again, it's called vibrational motion or oscillatory motion. So the motion of molecules of the solid is very slowly, so we can call it vibrational motion. It is limited, so we can't feel it. So because of the molecules are very narrow, there is no space or very small spaces between the molecules, so they keep its shape. They have definite shape. What about the attraction force between the molecules? as the molecules become nearer, as the attraction force increases, as the solid become more harder, become more stronger. So the solids have a rigid or hard property, fixed shape, fixed volume. Why? As we said that because the molecules of solid are narrow from each other. The attraction force between these molecules are very strong, so you can't break down a piece of iron with your hands because the attraction force between these molecules are very strong. So simply they can't be squashed. What's meant by squashed? To crush easily. Okay. What about liquid? Let's go inside the liquid, and so its molecules, you can see that liquid molecules, they are not like the solid. The molecules are away from each other, as you see. So the attraction force is less than that of solid. So they are not rigid. They have no fixed shape because of the spaces between the molecules and the lower attraction force between the molecules, so the liquid can flow. Then it has fixed volume, of course, as we said before, but it still has attraction force between molecules, so you can't, or the liquid can't be squashed. What about the gas? The gases, really, they have very big spaces between the molecules. What about the attraction force? It is nearly vanished. The attraction force between the molecules are very, very small. So you can see the particles of the air, each one the spaces between each molecule is larger than liquid, and the liquids are larger than the solid. So they can move easily. You can feel the gases around you easily more than liquid and solid. Its motion is freely, but here it's not free, and here it is limited. Okay, so what about the shape of gases? Yes, no fixed shape, no fixed volume, so you can press, as we said, if you have a balloon filled with oxygen or filled with carbon dioxide, you can press it easily. Okay, now let's speak about solids at first. And as we said that solids are substances that have definite shape and definite volume. What about its motion? We said that its motion is called vibrational motion or oscillatory motion. What about the spaces between each molecule? Very small spaces, or the molecules are narrow, so the attraction force between each molecules or the molecules is very strong, so it makes the solid with definite shape and with definite volume. So here the same, we said that solids retain a fixed shape and volume, don't flow easily, can't be easily compressed. You can't compress the liquid, the solid, unless we heat it, we change it into liquid. Okay, the particles of solid are in a fixed position, as we said before, because of the attraction force or the strong attraction force between its molecules. What about the liquids? As we said, yes, the molecules are away from each other, as we said, so it makes their shape excellent, indefinite. So here the juice, if I put here the juice in this cup, it will take the shape of this cup. If I put it here, it will take the shape of its container, because of let's return back to the origin reason, which is attraction force between the molecules, which is low, and the intermolecular spaces between the molecules, which are big relative to the solid. Okay, so again we said that molecules or the volume of the liquids here doesn't change. If I put here 1 liter of juice and here the same 1 liter, so the volume doesn't change as we said before. But we have to understand new properties and unique properties about the liquid. What's meant by unique? Unique means specific properties only for the liquids. The first one is called surface tension. The second one is called viscosity. Again, the first
Everyone knows what a huge splash you can make when you dive bomb into a swimming pool.
And let's see together
right on the surface,
this video.
the water feels high, which is why you can hear such a big noise when you land.
That's because of surface tension. All the molecules on top are pulled tightly together. They form a skin like a weak layer of plastic wrap.
As you see, the molecules at the surface
Here's
of the
a cool way
water,
of
they are
showing how
bind
surface
together.
tension works. Put some milk into a bowl. Make sure
This
it's
is a very
room
easy
temperature.
experiment you can
Now
do
squeeze
at
a
home.
few drops of food coloring.
What makes here the drop of the color still at its
It
place?
just sits
Can you
there
see?
because it hasn't
Because
broken
of
the
something
surface
which is
tension.
called surface tension.
But watch this.
The molecules
A
bind
couple
each
of drops
other.
of detergent
But what's
splits up the
happening?
molecules in the middle. And
Yes,
all the
excellent.
colours
What
are
is happening
sucked
here?
towards the edges. That's what happens when you break surface tension.
Yes, so break the surface tension so they will mix together. So again, return back. So what is meant by surface tension? Here, what makes the water drop form this spherical shape? Because the molecules in around or in outer surface of the water drop bind together strongly together, which keep the shape of the drop in the spherical shape. So what is meant by surface tension? It is the force acts where in the surface of the liquid to bind its molecules strongly together. So it's called surface tension. Here what is happening? The drop of water which is or which has the ant on its surface, and the water drop still in the spherical shape because there is attraction force here on the surface of the water which keep the spherical shape of the drop. Okay, let's watch another video.
Topic: surface tension. Why are drops spherical?
Because personally, I'm fond of spherical shapes as compared to squares.
Nah. It is because of surface tension. Surface tension is the property of liquids by which surface molecules of a liquid try to hold the liquid together by acquiring minimum surface area and acting like a stretched membrane.
You know what? Everything just went over my head.
Alright, I'll explain. Inside a drop, each water molecule is pulled with a force by its neighboring molecules. As these forces are equal and opposite, they get neutralized. However, the molecule present at the surface is not attracted outwards. It is attracted only inwards and sideways. Sideways forces get neutralized, but because of the inward force, each surface molecule contracts to form a shape that has minimum surface area, which is a sphere.
Okay, so surface tension, again, it is the force that acts on the particles at the surface of the liquid, so it keeps its spherical shape. Okay, the second property, as we said, which is unique for liquids, viscosity. What's meant by viscosity? You can understand viscosity if you have some honey and some water and some oil and start to pour them together. Which one will be slowly to move from the cup? Of course, the honey. Why? Because of this property, which is viscosity. Viscosity is the property of liquid's resistance to flow because of the large attraction force between the molecules of the liquid. as the attraction force increases, so the viscosity increases, and so on. Okay, so here, can you see the honey? It has higher viscosity, but what about the water? It can flow easily. So here, viscosity is the resistance to flow. Here, the honey has higher viscosity than the water. What is happening after heating the honey? The viscosity increases or decreases? Yes, excellent, decreases. Why? Who can tell me? Let's think together. Okay, because heating after heating, the molecules start to gain energy. Then they will start to move away from each other. So the attraction force increases or decreases? Decreases. Excellent. So the attraction force, which is responsible for viscosity, decreases. So after heating, the viscosity decreases. Okay. Now let's speak about the gases. What are gases? As we said, that they are substances that doesn't have a definite shape or definite volume because of the main reason. Who can tell me? Yes, excellent. The attraction force, which is very, very small between the molecules, and the big spaces between the molecules. So they are away from each other. So they have no definite shape or definite volume. As this balloon, gases have no definite shape and definite volume. Gases can be compressed very rapidly. What's meant by these words? If you press this balloon, it still as its volume, its volume will decrease and its shape will change only also. So the gases can diffuse very rapidly. If you open this balloon, they will spread everywhere easily. Of course, gases have low density because they are very light molecules. I'm waiting for your questions. Thanks.